Day 5 notes, graphing our complex numbers. So recall complex numbers are a plus bi, as we have here. So the real part is a, the imaginary part is your bi. So you have your two pieces to your complex numbers. So complex numbers can be graphed just like real numbers. Real numbers are graphed on a coordinate plane. So if you recall, here's your coordinate plane, x, y, you graph your x's, you graph your y's. That's what we graph our real numbers on. So as we remember, when we're graphing x comma y, we always have our points. You use your x, your y, and then you graph it. So complex numbers are actually quite similar. Since complex numbers have two components, the real and the imaginary component, they must be graphed in a two-dimensional system called the complex plane. So if you look over here to the right, this is an example of the complex plane, which I know, it looks exactly like what you've been dealing with before. It looks just like your coordinate plane that we drew up above. The difference is, there's your x-axis. I know that's the same, that's not a difference. But the difference is your y's. That is your y-I axis, is what we call that. So you graph the real portion on your x-axis. Your imaginaries go on the y-axis. So the horizontal axis is the real axis. The vertical axis is the imaginary. So not too much of a difference, but it does throw that little twist for it. So the graph is represented by is represented by a vector. Well, the line and an arrow indicating directions is also referred to as a vector because it has the arrow on the end of it. So they always start at the origin, and it ends at the point that you're trying to graph. So let's say, for example, I had the complex number 3 plus 4i. So as we were saying, this is your x, this is your yi. So on x, you would go over to 3, and then on your y's, you'd go up to 4, because it's 4i, so this is really a 4i. And then you would connect it, starting at the origin. Let me draw a much better line than that, anyways. Draw a line, connecting the two of them, and that's actually what it would look like. And then we would label it as 3 plus 4i. So it's a vector, a line with an arrow, so you can indicate the direction that it is going in, and that's how you would graph them. So what ends up happening is a lot of times they want you to be able to figure out the length of the complex number. So in order to do that, you have to figure out its magnitude. So the magnitude is the length of your complex number. So we figure this out by using your Pythagorean theorem. What ends up happening is if you took your complex number, drew a straight line down connecting you to the x-axis, you then created a right triangle. Remember your a's, your b's, and your c's. So you figure out your magnitude by doing a squared plus b squared equals c squared. And that's going to give you the length of your vector that you have there. So let's take a look at some examples. They want us to plot each of the following complex numbers on the complex plane and then find its size. So remember, when it tells you to find its size, that means its magnitude. So we're going to first graph 3 plus 4i. That's actually the example I just gave on the front. So let's try it again. So 3 is our x, so we're going to go over to 3, 1, 2, 3, and then we go up 4, 1, 2, 3. So we draw our line with our arrow 0, that's 3 plus 4i. So now to figure out its size. So to figure out its size, we have to use the 3, 1, 2, 3, because that's the length of this side. We use the 4 because that's the height of our right triangle if we connect it to our x-axis. So for our a squared plus b squared equals c squared, we would use 3 and 4. But you don't even have to use the graph over there, because if you look, here's your 3, here's your 4. Those are your two numbers you're going to use as your a and b when you're figuring out its size. So 3 squared gives us 9, 4 squared is 16. Add those together, we get 25. Take the square root and we get 5. So its size is 5. I'm going to erase those so we don't get too confused as we go on to our other examples. So let's try our next one. X is negative 7. Your yi is negative 1i. So we're going to go to the left 7, 1, 2, 3, 4, 5, 6, 7. Down 1, because it's a negative I this time. And there you go. There's your negative 7 minus I graph. So now to figure out its size, again, we're going to use these two numbers. And the number in front of this I here is a 1. So we're going to do 7 squared plus 1 squared equals c squared. You always use the positive versions of those numbers. You don't need to change those to make them, you don't keep them negative. You change them positive always. So 49 plus 1 gives us 50. So you take the square root. Perfect square that goes into 50 is 25. So 5 radical 2 is the size of our vector for that one. So in our last one to graph here, there is no number over here in front of 4. So your x is a 0. And then we're going negative 4i. So we're not going to go left or right any. We're just going to go down to 4i. There's your negative 4i. So then our a value when we're doing our size is 0. B is 4. And then we're trying to figure out, again, our c. So this becomes 0. This is 16. Take the square root. And the size for that one is 4. Pretty simple. Over here for number 2, in what quadrant does the sum of 3 plus 2i and negative 4 minus 5i lie? Well, let's first add them together. So 3 plus a negative 4 is negative 1. 2 minus 5 is negative 3i. So if I draw a little picture, negative, negative. So if I'm going negative, negative, we're down here in quadrant 3. If you forgot, this is quadrant 1, 2, 3, 4. Third one, they want us to graph the vectors of 4 plus I and negative 2 plus 3i and the vector of their sum to the right. So let's start with the 4 plus I. So there's my x, there's my yi, so I'm going to go to the right 4, up 1. There's 4 plus I. Second one. There's my x, there's my yi. I don't know why my eyes keep doing that today. So I'm going to go to the left 2, up 3. There's negative 2 plus 3i. And then they want me to graph their sum. Well, the easiest way to graph the sum is to figure out what the sum is. So I'm going to add them together. So 4 plus a negative 2 is 2. I plus 3i is 4i. So I'm going to go to the right 2, up 4. 2. And there's what they're looking for as far as the graph. They didn't ask us to find the magnitude or anything this time. They just purely wanted us to draw the graphs of them.